Okay, so for question 7, they are saying let f be a positive, continuous, and decreasing function. In other words, the integral test for convergence is fair game here because it's meeting the condition. So imagine if this is more of a conceptual question, but imagine you do the integral, you rewrite an infinite series as an integral, like we do with the integral test. If it comes out to be a number, forget that it's 4, but if it comes out to be a number, what does that tell us about the infinite series? Right, it has to converge, so D doesn't make sense. It's going to a number, not infinity or negative infinity, so that's why it converges. How do I know A is not correct? How do I know the sum of this doesn't equal 0? Isn't this always F is always positive? So if you take a positive value plus another positive value plus another positive value and you keep adding positive values, how's it going to be 0? That doesn't make sense. It can't add up to 0. So really what it comes down to is you know it converges because it went to a number, but then is it greater than or less than 4? So this is where that proof on the front page, again, I told you didn't have to reconstruct the proof, but it's trying to show you kind of what's going on there. Oh wait, let me scroll back. There's one important thing in here. Right here, we are starting at n equals 1. Starting at n equals 1. And on our proof, remember the left side, I kept it at n equals 1. Right here. Here's where n equals 1, the left side. So I know it's an overestimate. I'll come back to that in a second. But on this side, I added the first term to both sides. So that way, because notice this and this are saying the exact same thing. So if I'm trying to squeeze this in, then I need this to be bigger. If this is supposed to be greater than or equal to this, but less than or equal to this has to be bigger. So I only added it to this, which means that when I added it on this side, when I added this A1, that's like I'm saying, okay, I've already did the first term, so don't start at the first term, start at the second term. And that's why way down here, you can't really see on mine anymore, it said n equals 2. So if you're starting at n equals 2, it's an underestimate, and your answer would be less than or equal to the integral, so it'd be less than or equal to 4. But because we started at n equals 1, it was a left Riemann sum, which means it was an overestimate, which means that this infinite limit would be greater than or equal to what this is. And so if that was 4, and we know it's greater than or equal to 4, that's why you would pick that one. But this, again, the only way to really see that, and so you probably want to add some wording to this, this n equals 1 means you're doing a left Riemann sums on the front page, which means that when you do the left Riemann sums, the estimation ends up being an overestimate, which means that this stuff, if 4 is an overestimate, then you know the actual infinite series has to be bigger than 4, because this is too much, so picking bigger than 4 is what would make that work out.